We will simply be finding the product, and you need to remember from grade 8 what finding a product is. You actually started this in grade 1, if I'm not mistaken, where you multiply two numbers. Those numbers separately, we call them factors. Okay, when we multiply or divide, we call them factors. So when you multiply the factors, you will get what we call a product. So far, what you've been doing is just to multiply a monomial with a monomial, which is just one term with one term, like 2 times 3. That is one term multiplied by one term. The answer will be one term. When you multiply a binomial with a binomial, the answer will be it'll be a binomial, but in certain circumstances, it will be a trinomial. It'll only be a binomial when you when it's just a difference of two squares, where you have sort of like same factors in each bracket, but the sign is different, where one bracket is positive and the other one is negative. So we'll simply be distributing. I will start first by distributing. Distribution is simply multiplying out the factors in order for you to find a product. So we're gonna be multiplying monomial with monomial, binomial with binomial, monomial with binomial, monomial with trinomial, trinomial with binomial, and trinomial with trinomial. And you will get to know all of those as we go. Okay, the distributive law says that multiplying a number by a group of numbers added together or subtracted from one another is the same as doing each multiplication separately, but keeping the sign unless you multiply by a negative factor. So remember, when you multiply by a negative factor, it'll change the result. When you multiply a negative with a negative, so when you multiply same signs, your answer will always be positive. So your product will always be positive. And when you multiply a negative with a different sign, which is positive, the answer will always be negative. Here's one example here, where I simply showed you that if I have 3 added with 4, I can simply add 3 and 4. That will give me 7. 7 times 2 is 14. Okay. Or I can simply distribute the 2, which is easier, especially when you're dealing with big numbers. So you can simply say 2 times 3 will be the same as 2 times 3 plus 4 will be the same as multiplying 3 and 4 separately by 2 without changing the sign. So when you multiply 2 with 3, you will get 6. When in between you have plus, multiply the same 2 by 4, you will get 8. So 8 plus 6 will give you 14, which is the product that you will be getting. We'll actually go through this in detail in a short while. And for the second one, you will simply multiply 3 with 4x. 3 times 4x, that will give you 12x, and take the same 3 multiplied with negative 3, and that will give you 9. Okay, so that's how we end up having a product of 12x minus 9. That is a product which is a result of two factors, and that will be 3 multiplied with x, 4x minus 3. When you multiply a number or a variable by itself, simply add the respective exponents. So when you multiply a number or a variable by itself, remember to always add the exponent. Okay, 3 to the exponent of x times 3 to the exponent of x. Be careful. Obviously, if 3 to the exponent of x times 3 to the exponent of x will simply give you 9 to the exponent of x, but it won't work out if you have 3 to the exponent of x times 3 to the exponent of 2x. You can't say that is 9 to the exponent of anything. So be careful. So that's why 3 to the exponent of x times 3 to the exponent of x, because you multiply same bases, you simply keep the base and you add the exponent. Remember that rule. When you multiply same bases, simply keep the base and add the exponent. Okay. Let's find a product to a monomial with a binomial. We will simply distribute. So when we distribute, we will simply multiply 2 with the first term that is inside the bracket and multiply that 2 with the second term inside the bracket, which is 4. So 2 times 3x, that will give us 6x, and 2 times 4, that will give us 8. We can't simplify this any further because these are unlike terms. 6x plus 8, we cannot add them. They are not like terms. Remember I said to you, like terms are terms that have the same variable and the exponent of those variables must be the same. In this case, they don't have the same variable because 8 is missing x, so we cannot add them. That's why we're going to leave it as it is, and 6x plus 8. All right, let's multiply a monomial with a trinomial. The principle is still the same. You will take 2 multiplied with the first term inside the bracket, take 2 multiplied by the second term inside the bracket, and take 2 multiplied by the third term inside the bracket. So 2 times x squared, that will give you 2x squared. 2 times minus 2x, that will give you minus 4x. And 2 times 3, positive 3, that will give you plus 6. When you simplify that, you will get 2x squared minus 4x plus 6. Okay, let's multiply the following. Simply to say the same principle where we're multiplying a monomial with a trinomial. We note that inside the bracket we've got 3 terms because they're separated by minus. All of them are separated by minus. And outside we have a monomial which is 6x squared y. You need to remember that when you multiply such, you always start with the numbers and then you multiply the variables. And remember, keep this in mind when you multiply the variables. When you multiply variables that are the same, you simply add the exponents. Okay. So I will simply multiply the whole 6x squared y with 4x cubed y squared. Multiply the whole 6x squared y with negative 3x y whole, and multiply 6x squared y with negative 8x to the exponent of 5, y to the exponent of 11. Now, when you multiply the first, so it'll be 6 times 4. 6 times 4 will simply give you 24. How did I get that x to the exponent of 5? Note that we've got 2 to the exponent of, we've got x to the exponent of 2. So we've got this x to the exponent of 2. You need to multiply that with x cubed. Note that there you're multiplying the same base, which is x. So you will simply add the respective exponent. So when you add the 2 plus 3, that's why we have x to the exponent of 5. Similarly with y. This y has an exponent of 1, and the one inside the bracket has an exponent of 2. So you will represent it as s in y, and just add the exponent, which is 1 plus 2. The second term, I did the same thing. 6 times negative 3. 6 times negative 3 is negative 18. X squared times x to the exponent of 1, because there's no exponent there, the exponent will be 1. So you represent it as a single base, which is x, and you take this one here, you add it with this 2. Okay, when it comes to y, you're going to do the same thing. When it comes to y, you will simply say y to the exponent of 1 times y to the exponent of 4, which is represented as a single base, which is y, and you will take 1 and add it with 4. Okay, that's how we got that. And the last one will simply be 6 times minus 8 will be negative 48. And then x to the exponent of 2 times x to the exponent of 5, that will give you x to the exponent of 7. Y to the exponent of 1 times y to the exponent of 11, that will give you y to the exponent of 12. How did I get that 12? It is simply 1 plus 11. Let's multiply this. So we've got negative half times, well, negative half p q squared, which is simply a monomial multiplied by a binomial. In this case, inside the bracket, we've got 2 terms. Remember, when you multiply the variables with variables, and you multiply integers with integers. In this case, we really don't have integers, so you multiply numbers with numbers. And you'll know that the first term, which is 1 over 8, and remember when you multiply fractions, you always multiply the numerator with numerator, denominator with denominator. So I will simply take the negative half, multiply it by 1 over 8. So negative 1 times 1 will give me 1. So in my numerator, my product will have a numerator of 1, and the denominator will be 16. 16 is simply 2 times 8. Then let's multiply the p's. When you multiply the p's, you have p to the exponent of 1 times p cubed. That will give you p to the exponent of 4. And then you multiply the q's. Q will be q squared times q to the exponent of 1. That will simply give you q to the exponent of 3. Okay, so this is what we have. And the second term will be plus, because remember I emphasized this earlier on. I said when you multiply same signs, your answer will always be positive. So when you take negative times negative, it will give positive. 1 times 5, it is simply 5. In the denominator, we have 2 times 6, that will give you 12. Outside, note that we have p to the exponent of 1. Inside the bracket, the second term has p to the exponent of 1. So when you multiply p to the exponent of 1 with p to the exponent of 1, you write it as p, you add the exponents, which is 1 plus 1, and that will give you 2. Same with q. Q to the exponent of 2 times q to the exponent of 2. You write it as q, which is a single base, and you just add the exponents. 2 plus 2, that will be 4. 2 plus 2, that will be 4. That's how we got that q to the exponent of 4. Note that all I did was simply take this whole term, multiply it with the whole of the first and second term, and that's how I add the given product. Now here I still have a monomial. This outside term is a monomial, but inside the bracket I have 1, 2, 3 terms. So I've got 3 terms inside the bracket. So I have to take that monomial. Now when we start with the first term, I will simply take this 5 multiplied by 3. 5 multiplied by 3x will give you 15x. In the denominator, I've got 4x squared y multiplied by y squared. So I'll have 4x squared. But the y's, when you multiply them, this y here has an exponent of 1. So I'll simply take this 1, add it with the 2. So I'll end up having y cubed in the denominator. Now in the second term, we multiply the monomial with the second term. I will say 5 times 5, that'll give me 25. But it's 5 times 5 y cubed. It'll give me negative 25 y cubed. In the denominator, I have 4 times 8, which is 32. And then I've got x squared times x to the exponent. Because I'm multiplying x with x, I will simply add the exponent, which is 2 plus 4, and that'll give me 6, and then I'll have y attached to it. The last one will be 5 times 4, that'll give me 20, but obviously I will attach that xy to it. In the denominator, I have 4 times 7. 4 times 7, that'll give me 28, x squared y, and hence I arrived at this answer. Once you have a fraction, remember, as long as your numerator is multiplied out and your denominator is multiplied out, and you have variables that are the same, and the exponents of those variables are also the same, you just cross them out. However, if the exponents are not the same, you're going to take the exponent of the variable that has the lowest exponent and subtract it from the exponent of the variable that has the highest exponent. I'll explain that by just doing this example here. Note that I've got 15. 15 divided by 4, I cannot simplify that figure. But I've got x in the numerator, x to the exponent of 1 divided by x squared. Note that the x in the denominator has the highest exponent of 2 because the x in the numerator only has the exponent of 1. So what I am simply going to do here, I'm simply going to write the variable where the exponent is the highest. In this case, the exponent is the highest in the denominator. So I'm going to keep the variable in the denominator and simply take the exponent of the variable in the denominator, which is 2, and minus the exponent of the variable in the numerator, which is 1. And meaning that I don't have x in the numerator anymore, but in the denominator, I'll be left with x to the exponent of y. That is, x to the exponent of 1. How did I get that 1? It's 2 minus 1. 2 minus 1 is 1. And normally when the exponent is 1, you do not write it. And the variable y will still remain in the denominator as y cubed because there's no y in the numerator. term. The second term, I've got 25 divided by 32. There's nothing I can do with that. I've got x to the exponent of 6. Well, I don't have any x in the numerator. However, in the denominator, I do have y. So that y has an exponent of 1. What I'm going to do is simply to take that y to where I have the biggest exponent, which is the numerator. And I will simply take the numerator exponent, which is 3, minus the denominator exponent, which is 1. So I'll have 3 minus 1, and that will give me 2. So in the denominator, I will not have y. Instead, I'll have y squared in the numerator. Then let's simplify 20. Now, to simplify 20, we're going to find the highest common factor between 20 and 28. Remember this from last year. So which highest common factor does 20 and 28 have? It is 5. Okay, not 5, actually, it is 4. Okay, I'm dividing in my head now. It is 4. 4 goes into 20 how many times? 5 times. 4 goes into 25 times. But 4 goes into 28 only 7 times. Okay, let me just write this properly. Okay, let me just leave it as that. Let's go to the x's. We have a variable x in the numerator. We have a variable x in the denominator. So basically what I'm going to do now, I'm simply going to take the variable that has the lowest exponent, which is x in the numerator. Its exponent is 1. I'll simply take that 1 and minus it from the variable that has the highest exponent, which is 2, x to the exponent of 2 in the denominator. The y's, note that the y's will simply cross out because it's the same variable and the exponent of those variable is the same, which is 1. So you just cross them out. With the x's, note that in the denominator, I have only x to the exponent of 1, and normally do not write. This is what you'll end up having. Okay, moving right along, classwork. It should take you around 20 minutes to complete this classwork.